Hey, welcome back to DIY Fab Shop. I'm excited to share with you today an upgrade for the 3D printed alignment system that I shared a couple months ago. If you haven't seen that video, you'll see a link in the description below. All these parts and everything I'm going to go through here today is available for free download on my website, and anything that needed to be purchased, there's a link for in a bill of material and additional information on how to put this together. So I'm excited about replacing the strings with construction lasers. So in order to do that, I developed this roof-mounted assembly that sits up on the roof and has adjustments to make sure that these lasers are perfectly aligned with the theoretical center of the car. And by doing that, you can eliminate the strings. You don't need to have the conduit. You don't have something to trip over. And the other benefit is since it's mounted to the car, when you take any tension out of the suspension when you're working on the alignment, this will move with the car, whereas before I had the conduits mounted on tripods. That's an issue if the car moves at all. Here, the lasers will move with the car. So without further ado, let's jump into the CAD and I'll show you how it works.
Okay, we're going to do a quick overview here in CAD of the system. Obviously, a pretty significant portion of the system is this aluminum extrusion. It provides the backbone of the system, something to provide both rigidity and accuracy. And that is mounted to the roof of the car through these two bases. One of the bases here, the one on the driver's side, is more or less static. The one on the passenger side has some adjustment to it, and that allows us to set the angle of this beam across the top of the car. And on both the left and right hand side of the extrusion, we have the laser slider mounts. So in the brighter orange, the lasers mount inside these brackets and are attached to these sliders that can move along the rail, which helps again with adjustment. If we zoom in to the slider rails, this socket head cap screw is used for a coarse adjustment. In other words, it can slide this whole slider along the extrusion once loosened. And then there is a fine adjustment where this threaded knob can push and pull this carriage in and out along the extrusion with more of a fine adjust. And once it's in its final location, there's a threaded knob to lock it down in its fixed location. That rail assembly is mounted to the bases with a pivot mount. So these orange parts are just accepting a cylinder, a T-cylinder that can rotate within the bases and then can also pivot so that the angle of the beam with respect to these mounts can adjust. On the driver's side, the base is fixed, so it just pivots. This base does not move, it just allows the rail to pivot about that spot. And then on the passenger side, there is another threaded adjustment that allows this carriage to be pushed out or pulled in, which affects the angle of the beam across the top of the car. And again, once you get it where you want it, you can lock it down with this threaded knob. So really the adjustment is you can slide the sliders left and right to get the lasers where you want them in relation to the scale holders on the wheels. And then you go through a process of making sure that this beam is absolutely perpendicular to the axis of the car. And in order to do that, you use this threaded assembly on the passenger side mount to push and pull this connection, which pivots about this spot. So that's how we make sure that we align this full assembly to the car. And one last thing I wanted to share, these end caps, you'll see when we go through alignment of the laser, they have a function in that. But I also did put a couple holes in here to allow you to hang this beam assembly on the wall if you'd like to for storage. So let's jump over to a little bit of 3D printing. So I have a Bamboo X1 printer and I printed everything in PLA, and I just wanted you to realize that there's a lot of printing, but I have made it so that literally only one part needs supports to be printed. Everything else, the holes can be printed as is, and everything else that's an undercut has a nice generous angle to it, so it can be printed standing up or whatnot. The only part that needs support is the laser mount itself, and I like to use tree supports because they're pretty easy to pull out. All right, remember you want to head over to DIYFabShop.com, find the wheel alignment kit webpage, and on here you can find bill of material for everything in the laser system with links to purchase components. And then if you scroll down, you have all the bits and pieces from the other video for the wheel measurement system and the laser system. You can download all the STL files. So once you get all the parts printed and purchased, then you can go on to assembly.
All right, so there's actually quite a bit of repetitive assembly here, so I'm just going to show you things once. We're going to start here with the roof mount slider, and it can be identified by the fact that it's got 3 bosses for these magnets, and it's labeled with passenger side on the side. And I already got 2 of the magnets in, obviously very straightforward. You have bolt through design with a washer, a lock washer, and a nut. Okay, next we are going to install the adjustment threaded knob, and in order to do that, I have this little retainer washer that gets clamped into the system with a lock washer. So you put that in that pocket, you put through the threaded knob, and you tighten down the lock nut, and you just want to get it just so it's snug and will still turn. We're really just trying to eliminate backlash from the system. Obviously, it is a lot easier to do this with a power tool. Okay, I run it down and I went too far. It's too snug, so let me just back it off a little bit. And I have it nice and loose, yet not a lot of axial backlash. We're going to repeat that assembly of a threaded knob on 2 other parts, but for now we're going to go on to the slider plate. The design uses a fair amount of these riv nuts. I like using riv nuts in these 3D printed parts because you can pull them in and they have a flange to support them. There are other processes to glue in inserts from the other side or heat stake in inserts. I kind of like these rib nuts for pulling them in whenever you have bosses like this. So really you just get it started. And these are all sized such that you can just pull them in pretty easily with a bolt. Okay, to insert this slider into the slider base, what you'll see is that it runs on these surfaces here to help it stay tight and true. Well, if you try and run two of the same plastic materials against each other with a close fit, you'll get stiction. So I put a little bit of lubrication on these surfaces, and oil isn't the best for PLA, but I just used a little bit, and I just happened to have some assembly lube left over from my last engine project, so I just put the lightest a bit on those surfaces, and that really helped smooth up the system. Now when I go to assemble, I drop an M8 nut into this pocket, which is going to get threaded onto that screw. I turn this over, line up the parts, and insert it, bring it up, and start screwing it in. And whenever I go to set this up on the car, I want to be at the middle of the throw. So I'm going to keep turning until my gap here is about the same as it is there. And you want to remember that in between use and alignment, that you kind of have a gross positioning when you're just setting this on the car, but then you have a fine position when you're going to use this. And so you want to have all that stroke available. All right, so next we're going to install this nut pocket with an M6 nut in it. And this this M6 knob acts as a securing system, so that once we have this slider positioned where we want, we can tighten it down. So easiest way is to flip everything over, slide it over, align the holes, and get the thread started. And you can leave that loose for now. Next, we're going to attach our roof mount short tower, and that just uses some short M6 socket head cap screws. And finally, we are going to attach this pivoting T. This T pivots in this stand, basically an M6 bolt and a lock washer.
No.
And again, in this case, we're tightening it down just tight enough that this still moves freely. This helps take up the difference in flatness of the hood or of the roof of the car when we set this on it. So it's important that we have some compliance to deal with that. Okay, so now this passenger side roof mount assembly is essentially done. For the driver's side, we have a tower that's labeled driver's side, and it also gets a flexible T and 3 magnets secured. All right, now we have 2 of these laser mount assemblies to put together. This is the slider base. Again, very similar, uses a retainer washer. The knob has a lock nut on it. We've taken out the play, and we drop our M8 nut in, and we assemble that. Again, to start with, I'm putting an equal gap on either side of the translating movement and installing a nut pocket with a nut in it. Now, attached to this laser mount slider base is the rail mount, and if you look inside, you can see that there is a T-nut with a little M6 socket head cap screw. There'll be those on both sides. They're not the easiest to assemble, but it's important that when you look at the T-nut, you want the rectangular portion to face outside. So put that against the wall. And get that started. So I have 2 of those T-nuts. And then that gets fastened with 4 more socket head cap screws. And then onto the slider gets mounted this laser mount. It's got the 4 holes for the cap screws, and this is where the self-leveling laser will ride in that slot. Now for the lasers, what I used is this Klein Tools 360 degree self-leveling laser. And if you're not familiar with these, obviously they're very common in construction and used in the trades for electrical and plumbing as well to do nice alignments. But the 360 part is that laser actually rotates, and so there is a laser line 360 degrees all the way around these 3 different planes. So this is a horizontal plane, that's a vertical plane, and that's a vertical plane. And once we get this up in the car, we are going to mount, these usually come with a tripod mount. This one obviously does. And we're going to mount a 1/4-20 socket head cap screw through this slot and onto here. And that slot allows us to fine-tune and adjust where we align the laser. And I'll go through how we align the laser once we get this on the car. Okay, here we have the extrusion that'll go across the car. This is the pivot mount that bolts to the extrusion. On the bottom you'll see it has 2 T-nuts. We need to consider the orientation of those as we slide it onto the rail. And I'm just going to snug these up so it doesn't fall off. We'll actually set the location on the rail later. And then I'm just going to show you these end caps now. This end cap is going to live on the end. I'm not going to put it on until we get it in the car, but these also have the T-nuts inside them to secure it, and I'll talk about that a little bit later too. Okay, I wanted to go over a couple improvements to some parts since I released the first video. You'll recognize this as a rim touch-off part. And what I've done is I've made it a little bit wider so that you can place the scale down either to the left or the right. What that does is that allows you to put either the millimeter or the inches scale directly on center with the touch-off. And that just adds a little bit of improved accuracy to the measurements. Sorry I can't get this to focus, but on one side of the scale is millimeters, on the other is inches. And now when you use the 2-sided tape, you can either place it all the way to the left if you prefer inches, or all the way to the right if you prefer millimeters. Another thing is a few folks, the way their wheels were designed, there was not enough offset, so this little touch off didn't reach far enough. So I made it a little extension. You can download that as a separate STL if you can't reach all the way to your rim with just the standard part. So it's a little additional accessory if needed. And then also a part that I've added is this little pointer, and it goes in the center scale holder, and I'll show you how we use it with the laser alignment. It kind of helps speed up the process by setting a target for where we're going to place it, and so that just slides in that groove much like the trolley does, and provides a way to understand what measurement you're targeting. All right, we are going to start by putting the driver's side stationary pivot mount up here on the roof. And now remember, the first time we're placing this up here, we're really trying to get that rail perfectly perpendicular to the car. So it does matter how we put these up there. This is our first kind of gross adjustment. And ideally, you'd be equal distance between your two axles. I actually have an aluminum panel here that's a sunroof delete, so I'm going to be back a little bit. And I guess a word of caution, these magnets, you know, if this is a trailer queen or your, you know, prized possession daily driver, you might want to put down a microfiber cloth or something. You know, these magnets could pick up some little steel chips, especially in a working garage. You don't want to put those right on your paint. You got a track car or a race car like this, you probably don't worry about it too much. So I place that down. Okay, now on the passenger side, I'm going to put the adjustable sliding roof mount, and it's actually labeled with passenger side. I have the adjustment knob facing forward, and when I go to place this down, on both sides, the 2-magnet side is outboard, and I'm doing my best to get this aligned with the one I've already placed on the other side. All right. Okay, next is placement of the rail across the car. These pivot mounts should be loose to start with, and ideally I am equally spaced on either side of the car. And it doesn't have to be super perfect, but I typically take a tape measure and just check how much it sticks out on either side. And I was pretty close. And now I just snug this up a little bit. I'm actually going to leave this side loose. As we pivot about this side, the distance between these two pivot mounts is actually going to change just a little bit. So I'm going to leave this mount on the rail loose, and I'm going to secure the other side. All right, next come the laser mount slide assemblies. 2 identical parts, doesn't matter which side of the car they go on. Obviously the adjustment knob goes to the outside. And remember that when you slide this over the rail, there's these 2 T-nuts that live inside that have to have the right orientation to slide through the groove on the extrusion. And I'm just going to finger tighten those for now. Do the same thing on the other side. And next comes mounting the lasers, and I'm actually going to move the camera so you can see that a little better. All right, before I mount the lasers, I'm going to put the end cap on. And remember, the T-nuts inside have to have the right orientation. You slide that on, set it home, and tighten those down. The same thing to the other side. Now to mount and align the lasers, you'll see I did shut off the lights in my shop just so the camera will pick up the laser a little better. I have a 1/4-20 little socket head cap screw going through the tripod mount on the bottom of the laser. And then in order to turn this laser on, there's a little unlock switch on the other side. I do that, and then there's buttons on top to turn on the laser. Each one of them are independent switches. So this is the front one. And now I'm gonna just do a first initial alignment so that this laser is essentially perfectly parallel to the extrusion rail. And the way we align this laser with the rail is I'm going to look way down there where the extrusion touches the slider on that side, and I am loosening my 1/4-20 so I can slide this in and out, and I can pivot it. And so what I want to do is on that far end, I want to get that laser line right on the intersection of the rail and that plastic part. And I'm also, at the same time, aligning the laser on the back side of this plastic part. And I'll move the camera so you can see that. But you should be able to see the line down there. Okay, so presumably you can see the laser line against the plastic there. And also here. So right at the intersection of the extrusion and the plastic. So now I know that that laser is perfectly parallel to the extrusion. Now essentially I'm going to do the same thing with the laser on the other side. Okay. With that laser on, I am looking to see where it crosses the center scale holder on the front. And on the back. And I'm going to set a target of 60 millimeters. Okay, and this first adjustment is more of a gross adjustment where I'm going to move this whole support inward to get to that 60. I'm not going to use the fine adjustment until I get much closer. And to start with, on any car that I don't know the track width difference between front and back, I am going to assume that they're the same, so I'm going to set that same target. And then I'll talk to you about how to deal with the fact that many track widths aren't the same front to back. All right, kind of doubt that you can see the line when I wanted just down there, but I wanted to show you that my first adjustment is kind of a gross adjustment where I'm going to slide this whole thing in. And now that I'm close, I'm going to lock this down. even though I'm really close to 60 on the front, or the back, excuse me. Okay, so you can see that on the front, I'm not at that 60 millimeter target. And what that means is that the rail up on the roof is not perfectly perpendicular. So now is where I go to adjust that, because I want both the front and back to be at 60 millimeters. So I need the front to go out. And if I look, I actually have on the side of this some embossing that says front out equals counterclockwise. So I will turn this counterclockwise. And as I turn that counterclockwise, you'll see that that line is coming out. So at the same time that it was going out on the front, it's going in on the back because I'm changing the angle. So now I have the lines about the same distance off of the pointer, both front and back. Now I want to use my fine control to bring the line out. Here in is counterclockwise, out is clockwise. And I continue to adjust the knob clockwise until the line lines up with the pointer. So on the back, I have it about perfect. Back up on the front, that line is out a little bit too far. So again, I have to adjust my angle. This time I'm trying to bring it in, which is clockwise. Okay, so now I have the front right where I want it at 60. I have the back right at 60, and now I'm going to go to the driver's side. On the driver's side, I notice that in the back I'm out past 60, and in the front I'm less than 60. And the reason that is because there's a staggered track width between the front and the back. So what I'm going to do, I'm going to set the front right at the 60 using my fine adjustment. So with the front right at 60, now I go and see what the back measures. Now, the front measures 60, the back measures 68. So what I know is that that's about, if you take that 8 millimeter difference, I want to split that side to side so that I'm getting my rail perfectly perpendicular. So now I go back over to the other side, and I'm going to target 64 in the back on both sides while keeping the fronts at 60. To get 60 in the front and 64 in the back, I want the front to go in, which is clockwise. And then I'm bringing the entire beam out. Okay, by now using a combination of those two adjustments, I have the front at 60 and the back at 64. And now that I have those where I want them, I'm going to lock down these knobs. And go back over to the driver's side. Now with the adjustments I made on the other side, I need to pull the laser assembly in, so this front is at 60. And now I pulled the laser in, got it to 60 in the front. And if everything works out, I should have 64 in the back. Perfect. And again, now that I have it where I want it, I tighten up this adjustment. Okay, so quick recap, right? We wanted the laser system to be set up just like strings, right? So that we know we have two parallel lines, perfectly parallel to the theoretical center line of the car, right? So we set it on top, we did a gross adjustment, we then did a fine adjustment, and similar to how you adjust lines, making sure you're equal distant out, we did that with the lasers. A little bit more complicated because the track widths on this car are different front to back, so it adds another step where you first have to assume they're not, figure out a difference front to back, then adjust for that and split the difference. It's about the easiest way I found to do it with this laser system. Once you know what that is, you can adjust for that when you go to set it up. Now the question is it any more accurate than a string system? I don't know that it is, but I think it is easier to set up. I like the fact that I'm not knocking into strings, and I think now I'm going to set up the string system and we'll compare how close did these laser lines get to a string line. Now I purposely picked a number that wasn't exactly what those strings are going to be, so we're going to set I'm going to set up the strings, and then I'm going to just move the lasers in and out to see how well they mimic what the string measurement would be. So I'm going to do that and I'll bring it back. Okay, so I have my string laid and I've unlocked my fastener so this can slide in and out, and I'm just going to use the fine adjustment knob and I'm going to move that laser line into where the string is. And as I get close, you can see that it starts to land right on the string. And it follows the string from the back conduit all the way to the front. So that's pretty cool. It turned the fishing line into glow-in-the-dark fishing line. Let's check the other side.
And same on this side. The laser turned it into a glow-in-the-dark fishing line all the way from the back up to the front.
All right, that's it for today. Thanks for watching. I hope you enjoyed the video, maybe learned something today about how this could work. I'm hoping folks will give it a try. This is a little bit complex, so if you not the one to pay attention to details and put the time in to make sure you understand it, make sure that you have everything kind of set up and calibrated, so to speak. Maybe this isn't for you, because if you don't have a laser and you have to buy 2 of these self-leveling lasers, it's a pretty big investment and you might get frustrated. I don't want that. If you're the types to take on a challenge and like a DIY project and like the idea of eliminating the strings and making the system better, like I said, I think I can set it up faster than the strings, and give it a try. If you have questions, put them in the comments. I'll try and watch those and get back to you as soon as I can. Please like, subscribe, and share this with your fellow motorsports enthusiasts. And thanks for watching, and catch you next time on DIY Fab Shop.